Welcome back to the Cloudcast. I'm your host, Brian Gracely, and today we're going to dive into a topic that's been getting a lot of publicity lately, a lot of talk in the news lately, because there's a lot going on around standards and integrations, and we're going to dive into data. We're going to dive into the fact that so many of the things that we do every day, sometimes we take them for granted, but so much of them are based on our application's ability to collect data, to be able to sort it efficiently, and to allow us to, really kind of dig into, how can we ask it questions? How can it help us provide context around things? And so really excited today to have Alex Merced, who is Senior Tech Evangelist at Dremio, joining us today. Not only that, but also author of Data Lakehouse, Apache Iceberg, the Definitive Guide eBook. Alex, really excited to have you on the show. Really excited to dig into this topic today.
Oh, and I'm super excited to be on. Thank you so much for having me on. I love talking about data lakehouses. I love talking about Apache Iceberg. So I'm super glad to be here today.
Yeah. So before we dive into that, before we dive into, kind of all things data and how we keep track of it and sort it, give us a little bit of your background. You've been, we were talking a little bit before we even recorded, you've been focused in this space for a long time. Obviously, you're sort of the key person in explaining this. You're writing the book, you're the author of the book of it. Give us a little bit of your background and then where you really focus these days.
Got it. Yeah, I've had a really odd journey, but the long and short of it is I did spend about a decade before I wasn't even in tech, basically training people in the financial industry. So right there, I was already kind of taking really complex ideas and trying to make them really accessible, really understandable. Eventually, I decided to go to where my passion really lied, which was in technology, and became a software developer for a period of time. And then I found myself gravitating a lot towards working with like database modeling and database optimization and helping people like optimize the use of their CRMs. So I started getting more into the data space. I was always a big content creator, so getting into sort of like the DevRel, dev advocacy space made sense, and getting more into the data space made a lot of sense. So I ended up here where I got to really kind of be at the forefront of this sort of data lakehouse trend. So the last 3 years I've been at Dremio, just basically trying to keep my finger on the pulse of like all the technologies going around in this space and getting hands-on with those technologies, helping people understand sort of the trends and things to think about with these technologies, and sort of just really be sort of that voice to keep people aware of what's going on.
Yeah, no, that's very, very cool. No, it is a big, complicated space. So it's great to have people who, love and are passionate about, not only the technology, but also training people, teaching people about it, trying to take the complex and make it simple. So excited to have you on. It's been a little while since we've talked about data lakehouses. I looked, it's been probably more than a year. So I'm gonna start with something simple, and I told you up front, like I apologize for some of the simplicity, but give us a little bit of background on this space. So if you had to sort of paint the picture for somebody, where are we with data lakehouses? What are the sort of big challenges that they're trying to solve, and what are some of the trends that people should be aware of?
Got it. Okay, so I'll start off with just sort of a story to kind of set up what is a data lakehouse, and then we'll get into sort of like the problems it solves. But to really appreciate data lakehouses, we need to know what came before.
Yep.
And traditionally what we use is like databases, data warehouses, and they would abstract certain things from us. So they would abstract for us how the data is stored. How do we recognize that data as like table A and table B? How do we know that there's all these different tables? How do we catalog these tables? And how do I take an SQL query, parse it, create an execution plan, and execute that query? All that stuff was just nicely done for us in these boxes. Mm-hmm. And that works out great. The problem is that all these pieces are all sort of very vertically integrated to each other. So like each system works differently. So if if I need multiple systems, then I need to copy my data into those multiple systems, leading into the situation where I have to do extra work to move that data. I have consistency challenges in making sure that the data is the same in all these systems. And all that movement also delays me getting the data to the end result, whether it's a BI dashboard or training an AI ML model, whatever that end goal is.
Yep.
So the idea was, how about we only have one copy of the data? And one sort of place where we have data that's kind of accessible to all of our tools is the data lake. And the concept of the data lake is really just your storage layer. So you're storing data as files, whether they're CSV files, JSON files, Parquet files. The problem is you don't get the same kind of guarantees, those ACID guarantees that you would get in a database there, because you're accessing the data as files, not as tables.
Yep.
So when you go back and insert those missing layers, the idea of, hey, how about we look at the data as tables through a table formats like Apache Iceberg? Or, how do we track the listing of those tables through a catalog like a Nessie or Apache Polaris, you add those layers in, you do get all those guarantees again. And now you can interact with your data lake in the same way you would interact with a data warehouse or a database. Thus, that data lake becomes the data lake house. And that solves, one, the issue of, hey, I can now use many tools with the same copy of data. It's going to end up being a consistent version of that data. I'm moving the data less, so I'm getting the data faster. And overall, I'm also spending a lot less because there's a lot less compute work, a lot less storage that needs to be done. And since I'm not moving the data, there's also those egress fees that might happen. So I'm basically overall fixing my whole data world quite a bit.
Okay, so let me kind of poke at that a little bit. So one of the original problems was you would do a query of some data set, you'd get back an answer, but it didn't always have all the context that you wanted, right? Like you said, it was sort of narrowed to that one vertical silo that maybe the original application or the original data set was. So it was like, okay, let's try and bring all of our data together. Hence the idea of data lakehouse. You mentioned, you have this struggle of, well, everything was sort of kept in different formats and so forth. Apache Iceberg comes along. It's trying to provide a common, kind of interface, if you will, or common format to this, an open format for doing this. Do you essentially is Data Lakehouse essentially replacing databases then, or is it more of an augmentation of databases? If you're thinking, is that the right way to think about what you're doing?
Yeah, it's very much kind of going in that direction. I wouldn't say it's replacing databases in the way that, if I think of databases more for like application type workloads, that's not necessarily changing. But when I think of like data warehouses for analytical type workloads, that is changing. Even most data warehouse providers are moving in this direction, where they're allowing you to use their tools to access things like Apache Iceberg tables, because they realize that they still want people using their tools, but they're really realizing that the demand is to really just have a single sort of master copy of your data. Okay. And so everyone's kind of building in that kind of functionality right now.
Okay, so this is far less about sort of like transactions and more about analytics and being able to pull large amounts of information to do research and all sorts of things along those lines. Okay, makes a ton of sense. Makes a ton of sense. What are the typical integrations that you're seeing, with data lakehouses? I mean, is it more about sort of languages? Is it more about other data sources? What are the types of things once you've established a data lakehouse that you're having to integrate with, or how do you even think about integrations at that point?
I mean, at the end of the day, the main there's the two key pieces to really for that lakehouse that are going to determine which tools you can use with your lakehouse and integrate into your lakehouse. It's really going to be that table format, which in this case I usually talk about Apache Iceberg, and then two, the catalog, which is I typically talk about like Nessie or Apache Polaris. Although what's interesting in the Iceberg space is that you usually have a catalog, which could be one of many things, that tracks your tables. Okay. What Iceberg did over the last year is they developed this, what's called the Iceberg REST catalog specification, creating sort of like a uniform language for tools to talk to a catalog. Okay. So basically this makes life a lot easier, because before you may choose X catalog and it would limit you to the tools that support that catalog. Okay. But since all the catalogs can have the same interface, all catalogs can talk to all tools. So it allows that sort of very... having that sort of buffet of tools available to you quite easy nowadays, where basically anything that supports Iceberg can talk to whatever catalog you choose. And there's different reasons why you might want to choose different catalogs. For and there's a Nessie that actually provides like Git-like semantics to working with your Iceberg tables. There's Apache Polaris that brings things like the concept of external catalogs, where you can connect actual other catalogs to your catalog. So there's all these sort of different options that offer different benefits. And you right now is very much like that's where the focus is. I would say the industry, especially this year, there were two big events. One, Databricks purchasing a company by the name of Tabular, which was founded by the creators of Iceberg. That was a very big signal to the industry that, okay, Iceberg is here to stay. Yep. Two, Snowflake announcing Polaris. So initially it was a project announced by Snowflake. Since then they've contributed to the community. So now it's a community Apache project. Okay. But basically between those two movements of the two biggest players in the data space, signal that, okay, Iceberg is sort of the way you move forward with a lakehouse. Yeah. So now you're seeing that conversation go, okay, I know I want to use Iceberg, but which catalog should I use? And that's sort of where the space is right now. Okay. Yeah, no, that's helpful, because I feel like every time I
I sort of wander into the data space, and any project I'm looking at begins with Apache, there's always like 2 options or 3 options, and it feels like, yes, there's a reason there's multiple options, but the communities haven't sort of come together on it. So it's good to see that like you said, the market is essentially, at least some of the biggest players are signaling Iceberg is the direction they want to go with this. You may not necessarily choose that, but at least that's more where they're planning to go. So that's good to see. Give us some basics around Iceberg. Like, how does it fit into the bigger picture? Essentially, I think what you're saying is it is now sort of becoming the de facto open data format. It's the format that the marketplaces and the catalogs are looking. But what else is Iceberg providing in terms of what should people care about?
At the end of the day, it allows you to treat pretty much any storage system to treat it like a database. So instead of having to install a full and have a continuously running database system, you can actually have basically your data files, which are typically stored in a file format called Parquet, and these metadata files, and then them combined together, a system that understands the Apache Iceberg standard can then interact them with the same asset guarantees, the ability to update schemas, all the different traditional benefits you'd expect from a database or a data warehouse system. Mm-hmm. You get that sort of use form, which really at the end of the day means, hey, I can do SQL directly from my data lake from 20 different tools, which is really nice. And one really cool example, it's not just SQL. There's another startup called PuppyGraph that enables you to do graph queries on Iceberg tables. So this allows you to say, hey, you know what? I'm just going to use this one copy of my data to do my analytics, to do my ML, to do my graph queries, and in the future probably even vector work with the way things are going, and just be able to do it sort of in one format and without as many duplicates of the data, and make it easier to unify your data.
Okay. No, that makes sense. We were talking a little bit before we got started. We were talking about these sort of 3 trends, data lakehouse, data mesh, and data virtualization. Give us a sense of what are those 3 things doing? Where does the Venn diagram overlap on them? Why are those 3 things really important for people to kind of be aware of?
Yeah. So to me, those 3 trends really signify the really big question. The big question is, we have a lot of data.
Yeah.
And working with that bigger and bigger amount of data is becoming harder and harder for a variety of different reasons. And each of these trends address parts of that problem. So Data Lakehouse addresses the situation that I want to use many tools. Mm-hmm. The problem is that it requires me to make a lot of copies of my data. So by having by enabling a form where I can have one copy of my data that can interface with many tools, you've enabled a decentralization of tools that allows that scale of data.
Okay.
Then I'll do data mesh last. Data virtualization is a different problem in the sense that I do have a lot of data, but in different places. And the idea with data virtualization is having tools that allow me to connect to all those different places and interact with them as if they're in one place. Okay. And that also enables scale because I'm not moving the data around as much. So both of those are going to limit my data movement in different ways, either by enabling different tools or enabling many sources. And then third, data mesh is another sort of element of decentralization, but this is in the structure of how we produce data. So typically you might have a central team produce data for different business units. The problem is the company gets so big, there's so many different business lines at a point where that team may not necessarily have the context and expertise to provide not only provide the data in a useful way, but make sure that you provide the context and the knowledge and all that. So the idea is you break up the creation of that data into teams that run against sort of specific domains of expertise. And they create data products that represent that's basically you would actually have a bundles of data that representing each domain. And that makes it easier to provide good quality data faster and update it faster because you have different teams working on different parts of the data. Yep. And all of that together allows large amounts of data to be better quality, more accessible, and delivered faster. And basically, most platforms are, kind of moving in, starting to kind of recognize this. I feel fortunate that I work for a company that's kind of recognized that early and it's kind of been there. But that's sort of where I see sort of this question of how do you handle big data going. Right.
You hit on a couple of things that got me thinking. It's very hard these days to not have some sort of conversation that involves AI or generative AI. Where do you see, one of the big things that always comes up is as you talk to different companies, they look at, LLM models that are out there, whether they're proprietary or open, and they're first, there's always sort of two conversations that happens. One is, how could I get my data, my information, my knowledge into the model or influencing the model, right? And then the second one is like, how do I protect the model from, giving away bad data or us? Like, where do you see the intersection between people trying to influence LLMs for their business and these data lake houses that obviously store a ton of the data? Like, where do you see the intersections and integrations happening so far?
Mainly, the big issue is, as you said, people want to build AI models and they want to build LLMs. The problem is you need data to fuel these things and train these things.
Yeah.
The problem is in the status quo now, having this sort of fragmented data world in most places, because every department has been kind of doing their own thing separately from each other without any kind of coordination, it makes it really hard to kind of wrangle that data.
Yeah.
So Data Lakehouse helps put all that data and move that data into sort of a central place to more easily feed those models. And then when you throw in some data virtualization, help connect to external data. So you might be, let's say, purchasing data from like a Snowflake marketplace or the AWS marketplace to enrich the data you have on your lakehouse. And then you're able to build that internal lakehouse much faster when you break up the building of it into teams, the data mesh approach.
Right.
You're going to have much more quality of data. And then there's some technological pieces. Like that one catalog I mentioned, Nessie, that allows like the Git-like semantics. That's going to allow people to, when they create data and they make changes to the data, to be able to do that on a branch and run quality checks and make CI/CD pipelines that can ensure the quality of the data before it goes into an AI/ML model for better results.
Gotcha.
So having data that's more accessible and produced more quickly is going to allow you to train those models faster and to see those projects to completion much better. So a lot of people want to kind of rush to the finish line of having an LLM, but first you got to have your data house in order to really get there.
Right. And that's the piece that's becoming more and more obvious to me is, the LLMs get all the headlines, but if you're not doing good data governance, you're not doing sort of good data quality and scrubbing and everything, the LLMs essentially sort of become almost useless, or at least partially useless in terms of what they're spitting out for you. We're talking about large amounts of data. We've seen a trend over the last couple of years. For example, we've seen folks like Snowflake say, hey, we're seeing customers cut back doing, from 5 copies of their data to 2 or 3 copies for cost reasons and other things. Because we're dealing with so much data, are you starting to see companies either pull that back on premises, or are they doing more work in more distributed ways where, it's not all sorted in the public cloud, there's stuff happening on-prem, or is location becoming more and more of an issue or a, consideration for this?
Yeah, I would say like the hybrid world is becoming a bigger and bigger trend. Like this is like Dremio, we uniquely are deployable in the cloud or on-prem. So and we can connect the sources of them both. So we oftentimes are talking to customers who are running into the situation where they need data. Sometimes they need data on-prem, either for regulatory reasons or because like the regions that are available with a particular cloud, they would be better off having something physically located closer to where their particular setup is.
Sure.
Or, they want to literally have, like basically a real physical setup right next to where the AI/ML model training is going on.
Yeah.
So there's a couple different reasons they see that. And then some people still want to use the cloud because the regions are there. It's much more accessible to their users. They have access to different marketplaces.
Yep.
So then what they'll do is they'll bring in a tool like us, Dremio, to kind of unite and be able to see all that data from one place. So you can connect your Snowflake, you can connect your on-prem MinIO data lake or something like that. So I am definitely seeing a lot more of that, and a lot more companies trying to explore that. Also for cost reasons, as you mentioned, where people are saying, okay, well, I got to a point where my scale of data and basic consumption-based pricing at a certain point is cheap when you're at a small scale, but then as you grow, it can sometimes that cost calculation becomes different. Like this is like, I remember like last year, I can't remember what company refactored all their AWS Lambdas into one big mono repo for the same reason. So you're starting to see that where they're trying to figure out, okay, hey, where am I cost efficient with cloud? Let me do that with cloud. And where am I cost efficient on-prem? Let me do that with on-prem. Yep. And I need tools that can kind of unite that. And that's generally where we play. So that's why I do get to see all that a lot.
Interesting. Yeah. We haven't, you've done an awesome job of sort of, filling us in on the details around the market and the technologies. We haven't really talked about Dremio at all. The work that you do. where does Dremio fit into this bigger picture? What's your role with Apache Iceberg, and ultimately, like, what types of problems do you guys solve on a day-to-day basis?
Got it. So Dremio, basically, we are what I would call a data lakehouse platform.
Okay.
And generally, we have sort of three main sort of pillars of value. So the first one is unified analytics. So the idea that that's the data virtualization piece where you can connect all your different data sources, your data lakes, your databases, your data warehouses, your data lakehouse catalogs can all be connected in one place. You can see all that data in one place as if it were one big database and run joins against it with our query engine. The second piece is the query engine, which is really, really fast. Like, bottom line is you can get query performance on your whole world of data that is about equivalent to using data warehouse platforms where you're only getting that performance on just the data you have in that warehouse platform, but across your entire data world. And that's done because we're one of the places where the project Apache Arrow originated of, which has become a big thing all over the data place. Like, everyone's starting to add Apache Arrow for data processing, getting that better performance. We also have a very unique feature called data reflections, which I may get more into detail later if we have time, because that's probably the most unique, really exciting thing in the platform. And then 3, we have lakehouse management. So if you do want a lakehouse, especially with Apache Iceberg, we try to take a lot of the work out of it, in the sense that we have a catalog that's built into our product. So you can basically, you just set up and you're ready to start making tables. Our catalog can also help automate a lot of the maintenance and operational stuff that has to be done on your lake. So that way you can just focus on really just curating your data and working with your data lake as a data warehouse. So basically, along those 3 tiers, we connect all your data and make it easier to execute Lakehouse. And our actual interface really enables collaboration. So that way you could have different teams completely separately working across those different sources, curating those different data products to enable data mesh. So all in one place, you really kind of enables sort of data at scale, plus the ability to deploy in the cloud and on-prem allows people to really kind of design the deployment they need for their particular purposes.
Okay, very cool. So, I mean, so essentially, if somebody's like, look, this is what I want, I don't necessarily want to have to, staff experts in every single area. You guys, it's easier to set up, it runs faster, it's easier to manage, and then folks can just focus on sort of the business aspects of what they're trying to do with the data and the application, if I'm understanding that right.
That's right. I mean, we definitely like to call ourselves like the easy, open, fast platform. So like you said, we're easy to use, we're really fast, and we're open in the sense that we try to leverage things like Apache Iceberg and open source catalogs and whatnot, so that way you can connect your data. So if you want to take that same data, those same tables, and then run it with a different tool, you can, because we're using open formats. So your data is still yours. Yeah.
What I'll sort of wrap up, because I know obviously you're very busy. What are 2 or 3 lessons that you'd pass along to people if they're either exploring this space, they're looking to expand what they do around data lake houses and so forth, to get better results out of it? Like, what are some of the lessons learned that you can pass along to people?
Got it. I mean, oftentimes the challenges are choosing a catalog. Like, that was a lot more fragmented space. Nowadays, you could probably really choose one of the main catalogs. So this would be like a Nessie or a Polaris, and be in pretty good shape. Or use an integrated catalog, like something like what Dremio's managed catalog. Any of these work fine now. The switching between catalogs is easier. The interface is more open, so it's less of an issue. Another, oftentimes, sort of question. Actually, yesterday I had to talk to several different customers, and one of the patterns I'm starting to see is that once you adopt a lakehouse, you have to think about sort of how you split up your tables, partition your tables. And depending on how you slice up your table, you might end up with a lot of big files or a lot of small files. You prefer the big files. So this is where I think Dremio offers a lot of value with its reflections feature, because instead of having to kind of get your partitioning right away, what you can do is, if you're bringing in data, partition it based on date. So your Iceberg tables are partitioned based on date, which makes managing those tables much easier. Makes like how often you run optimization very clear, because you have a sort of a cadence of, hey, this is when the partition begins and ends. It's a daily partition, so we optimize once a day. But you're going to want to optimize for different types of queries that are coming in. Reflections in Dremio, they allow you to sit there and say, hey, I want Dremio to kind of manage a version of this data set that's optimized for these types of queries. And then Dremio will keep it in sync with that original data set, and Dremio will match it up. So that way, for the user's end point, there's only one table. And that table is going to be fast And managing that table is going to be easy because the partitioning is very simple from the data engineer's ingestion point, and then Dremio will manage all the complexity in between to make that work. Gotcha. And I think that that came up in like 3 conversations yesterday, and that basically made it clear, like, okay, hey, this is a place where like that particular feature in Dremio really makes sort of the design of an Iceberg Lakehouse much, much simpler, because that one question of like how you partition your tables can really make a difference in how the table performs because of the way it physically will manifest those files.
Yep. I mentioned it really briefly when we got started. You are the author of Apache Iceberg, the definitive guide. We were talking about it before. This has sort of been the last year of your life. What for anybody that goes out and grabs a copy of it, we put a link in the show notes. What are you going to get from reading the book? What are some of the sort of things that you're hoping people take away from the information in there?
My thing is, I really want to encourage people to get hands-on, and there are definitely many chapters where we go painstakingly in detail to enable you to go hands-on. I'm a big fan of creating like Docker compose files, so that way you can create full-on data lakehouse environments on your laptop that you can play with, and that's included in the book. I also have written several blogs where I've done that, so if you look up my whole blog history, you'll find plenty of tutorials. But main thing is I encourage people to get hands-on. When you read the book, you will get hands-on. You will get a better idea of the landscape and the decisions you have to make to architect that lake house. If that's something you need, you hit that scale of data where this becomes necessary. But basically, main thing is get hands-on. Once you really try it out, you really kind of start to see the value, and you start saying, this is not so bad. This is not so hard when you have the right pieces working together.
Yeah. No, good stuff. Alex, I'm going to wrap it up there because we could go into a ton of detail, a little bit tough to do on the podcast and audio medium, but we're going to put a ton of links in the show notes for folks, everything from the blogs that you have, the book, a bunch of the Apache projects. Folks, if you're a Snowflake user, if you're a Databricks user, they've obviously signaled to the market that Iceberg is the direction they're going. So we wanted to make sure we were covering this space. Obviously, it has ramifications for people doing any sort of analytics, and then eventually it'll have ramifications for doing things around Gen AI. So Alex, thank you so much for the time today, educating us, giving us some basics as well as some more in-depth stuff to dig into. Any other places you'd like people to go to kind of follow up on some things or reach out to you and your team?
Yep. I mean, a lot of those blogs that I mentioned are going to be over there at dremio.com/blog. I also run another website called DataLakehouseHub.com. And you can also find all my links to everything at alexmerced.com pretty quickly. So you can find all my social media stuff and podcasts and all that fun stuff. I like to talk a lot. So
yeah,
hopefully
cool.
You enjoy those.
Yeah, we'll get all those in the show notes for folks as well as they're listening. So Alex, again, thank you so much for the time today. Appreciate you educating us. You've given us a lot of basics to go from, and then obviously lots of in-depth stuff to dig into for folks that are into this space. So with that, I want to wrap it up. On behalf of Aaron and I want to thank Alex for his time. Folks, thank you all for listening. We've been getting a lot of really good feedback lately, some nice recognition for the show lately, and a lot of good questions from you as well. So if you have questions, show@thecloudcast.net. It's always the best way to reach us, or hit us up on DMs or any other social media platform. But with that, we'll wrap it up, and we'll talk to you next week. Cool. Give it 1 second, and we will be done.
Awesome. That was fun.
Yeah, easy. It should stop here in just a second, and then
it was like
there
99%.
Okay, yeah, it's doing the upload. It usually takes just a second, depending on how fast the internet connection is.
Yeah, my internet connection is pretty fast, but for some reason it's taking a second on that last percent.
It's always the last percent.
That's fine. No worries. But, I can leave it on.
Hey, do me a favor if you get some time. Drop just in the show notes that I sent you over. Just put the links to your stuff to your page, the blog page. That way, if anybody's listening, they're always like, "Oh, okay, I can go check the show notes and make sure everything's good."
Got it. Okay, I can do that.
And yeah, if you've got a drop, you can just like leave this screen on for a bit. It usually finishes up just a second later. But yeah, just please don't cancel it out because it.
No. Yeah, I know. I've used Riverside before, so I know not to do that. I'll just leave this up. I'm gonna actually do the cloud, and I'll just go put in those links right now while that uploads. Nope. Yeah, I don't know why is it stuck on that 99%. That's weird. Oh well. Give it a second. Oh, okay. So, yeah, it's been stuck at 99 for some reason. Like, it got to 99 really, really fast, and then, um, so is it? Yeah. Okay, let's let it do its thing. It still says it's recording. Would that be affecting it? Like, I still. Okay. Sounds good. Okay, cool. Uh, oh, okay, I can see it right here. Okay, perfect. I didn't realize I could just drop that arrow down and see the progress. So 599 of 605. So we're almost there. Oh, 602, 603. But another number went up.